Ever wondered why some AI models write like a human while others stumble? Let's unravel a groundbreaking study comparing three language models: Transformers, Reservoir Computers, and an upgraded version called AERC. What makes these systems tick, and how do they stack up when it comes to speed, accuracy, and efficiency? First, let's break down the basics. All three models tackle the same task, predicting the next character in a sequence, like finishing a sentence. But their approaches, worlds apart. Transformers, the giants behind GPT, use attention mechanisms to weigh every part of a sentence against every other. Think of it as a detective methodically cross-referencing clues, super precise, but computationally heavy. Enter reservoir computing. Imagine a sponge that absorbs and rearranges data in a way that makes it easier for the next layer to process. Traditional reservoirs are simple, fast, and energy efficient, but they lack the nuance of transformers. Enter AERC, the attention-enhanced version. It adds a dynamic, focus mechanism, blending the speed of reservoirs with the smarts of attention. Researchers tested these models on Shakespeare's texts, a classic challenge for language systems. They adjusted parameters like reservoir size and hidden dimensions, keeping the final layers comparable. The goal? To fairly measure performance against efficiency. The numbers tell a story. Transformers dominated in accuracy, delivering the lowest error rates. But here's the twist. Reservoir models, especially AERC, outperformed in speed. Why? Transformers' attention mechanisms scale quadratically, meaning as sentences grow, their processing time explodes. AERC and reservoirs, however, scale logarithmically, like sprinters versus marathon runners. This isn't just about speed. Reservoirs use far fewer resources, making them ideal for edge devices like smartphones. AERC strikes a balance, offering better accuracy than traditional reservoirs without the full cost of transformers. But transformers, they're still the gold standard for complex tasks, even if they're power-hungry. So what's the takeaway? Efficiency and accuracy aren't mutually exclusive. This study shows that simpler models with smart tweaks can rival giants in specific scenarios. As AI evolves, these insights could revolutionize everything from real-time translation to medical diagnostics. But here's the real question. Will we see a future where reservoirs pen sonnets, or will transformers remain the undisputed champions? The answer might lie in how we balance speed, power, and smarts. Thanks for watching. If you want more deep dives into AI science, hit subscribe. Stay curious and keep exploring the mind-bending world of machine learning.